Hello, everyone. I'm very pleased to announce the third article on information theory on my blog, niledatahub.com. This article is about Huffman source coding algorithm. And this is a follow-up on the second article, which describes the Shannon-Fano algorithm. This particular algorithm, which is Huffman, is optimal because it took a different approach to the construction of the source coding algorithm. It recognized the issues with the Shannon-Fano algorithm, which is a top-down approach that tries to force the probability distribution into two equal groups regardless of the individual probabilities of the source symbols. So what it does, as a reminder, it tries to divide the distribution into two equal groups, and then it does this recursively. It takes each group and tries to subdivide it into two equal groups regardless of the distribution of the individual symbols, and it does this recursively all the way to the bottom. And this introduces inefficiencies because that depends on the individual probability of the individual symbols. Huffman, on the other hand, is a bottom-up approach where you start from the bottom of the tree and assign the probability distribution of the symbols. So that guarantees that the least frequent symbols are at the bottom and the most frequent symbols are at the top. So the longest codes are at the bottom and the shortest codes are at the top. By design, you don't have to force it. And the way it constructs the probability distribution is you pick out the two least probable symbols and then you merge them into a node, and then you do this process recursively. You pick out the next two least probable symbols regardless of their values, combine them into a node, and then you work your way up the tree all the way to the root. And then come the point where you start to assign the binary codes. You start at the root, and then if you go left, you assign a 0. You go right, you assign a 1, all the way to the leaves. And then when you start to assign the individual code words or the binary codes for the individual symbols, you basically track your path from the root all the way to the leaf, and then you read all the zeros and ones from the root all the way to the bottom, all the way to the leaf, and that basically constructs the individual binary codes for the individual symbols. And if you go through the process, you'll find that this gives you the average, the most optimal average code word length for the source. And in that article, I describe, I go through an example where I compare Shannon-Fano algorithm and a Huffman algorithm, and I show that in that case, Huffman is optimal and it's associated with a higher efficiency and less redundancy. And redundancy is basically the penalty you have taken because of the inefficiency in the encoding process. And it's the extra bits you're incurring because of the loss of efficiency in the encoding process. So go ahead and check it out and let me know if you have any questions. And please subscribe to the blog, and there's a subscription button on the article itself and on the homepage. Thank you so much, and looking forward to your comments and questions. Thank you.